My name is Toni. I'm Toni Rodriguez, and my speech is about the mobile devices, how it's going to be easy to infect this kind of devices and control them by a control and command server. And this speech is an effect of my research in my master's degree of cybersecurity. And I choose this topic because the companies gives a lot of important. Sorry, there is something like the people doesn't take into consideration when they are doing some kind of security researches. And this is that for example we got. Oh, sorry. That we have, for example, mobile devices by everywhere in every time where we are, and daily we use them more than any kind of other device, and this is a good way to attack someone. Here you can see some information about that. So here is the time where I was doing my bachelor degree, and after I am doing now my master degree in the University of Adam Mickiewicz. And the specialist, my specialty is cybersecurity, and also I am working as a software developer in the geographical spatial system industry, which is in relation with doing maps and geospatial systems. And at the bottom you can find a contact for me. So we have here the agenda of my speech, and I'm going to split my presentation in two parts, because one of them is about how to make an malware to Android systems, and the second one is how to treat the data we have took off from this phone. So at the beginning, I would like to speak about the stats in the Android world. And as we can see in this picture, the Android users today, there are 3.6 million expected Android smartphones. So this is a huge number or targets which we can attack. And also in the Android world, there is something like difference between the APIs, and developing for Android is such a nightmare because there is not so easy way to make compatibility the applications we have developed for some kind of API. But we can see here that, for example, the 12 API, which is API 31 Android 12, uses the 20% of the world still. So we have here the number of target devices which we can attack if we have an application which is done for this API. So I would like to speak now about the malware distribution, and there are some ways to craft this kind of application. And the first one, and the most obvious, is to write your own application. And the disadvantages of this kind of way is because it's very time consuming. So you have to write your own app. After all, you have to reach the users to get deployed your malware. And it's not the best way to, for example, do a big attack which is controlled by one server. From the other hand, you can make something like the compilation of the code and trying to attack some application which is already installed in someone's phone. And this way is also hard because you can decompile the code, and you have to have a good understanding of the Android ecosystem, and also which is the ecosystem of the application itself, because you have the possibility to, for example, exploit web views or other kind of components. And not always, but mainly the application is hard to obfuscate, and it could be extra effort to make this kind of attack. But the best way, and I think the less time consuming, is to buy an app. And we have here on the right side an example of a page which sells applications. And this is an application which has a lot of installations, as we can see, and is really, really cheap to buy it and, for example, inject our code inside and trigger a new update to the users which have this application already, and they have granted these permissions to this application before. So, after all, I'm going to talk now about the spread of this kind of malware. And we have also some ways how to do it. And the main important way, which is now the most popular, is to make phishing and, you know, something like spread via SMS, direct messages or mail, which you can see in the second figure. Here is some example of the COVID campaign to download malware to phones. And also we can use something called proxy apps, and this is one application which has only one permission to request install packages, and this can be distributed via Play Store because it's not a very yeah, of course it's a permission which is very dangerous, but it doesn't make any kind of special difference for the Play Protect algorithm. And as we can see here, fake document manager app downloaded hydra banking Trojan. This is a headline for one of the here log article, which was downloading hydra app Trojan in some devices. And the third way is to install a PWA, and the PWA is something like an embed web application which can have the same behavior as a native one, and we can use some kind of attack vectors like HTML or manifest injection in them, or every kind of vulnerability we can have in the browser and also in the service worker. And this is the third figure here. Here we can see that we can download this application and install in the home screen as a normal one. Here we have an example how was the hydra banking malware installed in the phones of the people. And as you can see, there was a proxy app which was a document PDF reader. He was asking for install new update. After all, we got another view which is asking for granting the permissions for to download packages from unknown resources. We go to the next step, and the last step is that the user has two applications with the same icon. After all, this icon will be hide, and the only application he will have is this PDF bank hydra Trojan inside. So now let's speak a little bit more technically, because in Android there are some in the framework of Android there are four main components that you can use to create an application. And one of them, the most important, is an activity. And the activity is what the user sees when he is using the application. The second one is an intent, which is something to retrieve activity. And the third and the fourth are something which is going to work in the background, but one is used to send signals to the system and is called broadcast. And this kind of component is used only to, for example, let the application know if someone has connected to the Wi-Fi and do an upgrade if this is then if has this kind of signal. And this is work as the normal broadcast in the network understanding. So he's sending a signal, and who has this signal registered says, hello, this is me, and I'm going to get this signal. But at all, the broadcasts are not designed to send data in them. But in Android, we can do something like that to send something called a map in Java or something called dict in Python and send data over this channel. And also we can make a loop of this sending broadcast. So the other application which has a receiver implemented can have the data from the first one making a loop through every kind of signal the first one is sending. And the limitations which has this kind of method to send data is that we can send only strings, and they must be up to 1 MB. But we can, for example, take a photo, make a photo, encode it as base64, and send chunks to other application. And the most important here point is that the first application has a permission to read the external storage, and the second one don't have any kind of permission. So here is an example how it works. As you can see, there is my photo, and there is the photo which is placed in a downloaded folder in the system, which is in external storage. And I have a SCAM application which has a cache where I'm going to save this photo, which is going to be sent from the previous one, which have been before injected the code. Here is this application, which is called malicious image app. It has the sender broadcast. He's sending now the data which was parsed as base64. And after all, we can see in the cache folder from the other application, there is a new text file with the base64 chunked at all receive data, which we are going to approve that it's the same decoding it here in a page. And we can see that the second application has the photo from the first one. Also here I am showing that the first application has only the access to the media, and the second one has no access at all. And here we have the process in an image if it was not understood. So let's talk about something to bypass the internet connection, because the main goal doing this project was to make a malware which is not going to ask for any kind of permission to the user. And here we have an example that, for example, in which an application can use an intel of Google Chrome to open some kind of URL to get into a page and go back using something called deeplinks. For example, when we are using application like Facebook, Shane, or something like that, we can, the moment when we click on some article and it asks you if I have to open it in an application or not, this is the use of a deep link. And taking into consideration that every kind of phone or Android phone which has the Play services has a Google Chrome installed, so it could be working in the 99% of all Android systems which we have. The only thing we have to do is to register some kind of schema that this application has. For example, this application is called scam resp, and we have to trigger or make a redirect directly from the template or from the server side. So here we have a link which is going to send the data back to the application. Now we're going to see how it does. So we have here the manifest. We see at all that we don't have any kind of permission to use internet in this. We have the host already as a variable set. We have here the intent which opens the Google Chrome, sends some kind of data, and we can see here that this is the data which has get back from the server, and at all this application don't have any kind of permission to go to internet and is receiving data back from Chrome, because we can open the Chrome with a specific URL. And here is all the POC, which shows how to use this kind of thing, of this method to make a communication with the server. We can see here that we have registered this device as a with a super cookie, which is something called ever cookie or super cookie, that we are saving cookies in all the ways that a cookie could be saved in the storage of the phone, of the browser. We are saving the cookie in a local storage, in a cookie storage, in a session storage, and if some of the cached information is erased or is flushed, this cookie is going to be revived from other place than only the cookie storage. So this is a cookie which is invincible or every time is going to be live. So, and the last thing that I'm going to talk is about how to bypass the need to the user to click into the application to go inside, because, for example, the difference between a native Android application and PWA is that the Android don't have the permission to ask the user if it has to show notifications, and the PWA has to have something like a push or a push subscriber or a push publisher. And at all, this is a good way to exploit, also to weaponize the application. When you want to send something to this application, we're going to send with a parameter, and we're going to generate a notification which will have, for example, the comment or any kind of phishing layout that we are going to show it after. And if the user is not using the application for a long time, we can set an alarm manager which is going to say, okay, now as 15 minutes has been passed, we have some news for you, for example. So here I'm going to combine everything that I was talking before, and there is an example where we have the command and control server at the left side. And on the right side, we have an application which tries to be something as a news application, but it's really a scam application. We are setting the command we are going to send to this application, and we see here that the command is waiting. This is the Facebook command which have been sent. We have here a notification from Facebook after opening the application. We can see that you have a data breach in Facebook and you have an icon of security. We have the place to put the user, the password, and this at all after is going to be sent to our application. If you make now a refresh, we can see that we have the Facebook and also the device name and the ID of the phone that we have registered in our command and control server. So there are many ways to make a connection to command and control server, and one of this which I have shown is only to send query parameters via Google Chrome and going back to the application via deep link, but we can make use of other kind of protocols. For example, MQTT is a good way to trying to control a malware in Android, and also it needs structure of a broker or something like a publisher and subscriber. And we can see here that the send a command and control to an output of MQTT, how is the structure of this kind of use. And also we can use the peer-to-peer, which we know from all the life, and it's something like the torrents peer-to-peer connection. Also, we can have something like a cookie or a super cookie, which I said before, for example, to identify the malware we have already installed in someone's phone, and we can identify by a super cookie, which is retrieved the first time he gets into some kind of link. And also we have a PWA registration, which can work also as a super cookie. When someone's installed our application, the PWA sends is shooting to some kind of API REST to give back a response with a cookie or a response with an ID of this PWA device which have installed the application. And also there are other ways to do it, which are in the last years very popular. One of them is, for example, use Discord channels to try to control this kind of applications, or use Telegram bots, which is a lot of this kind of attacks in the mobile devices world now. Also from the old school, we can use something like a RSS channel to send comments, or we subscribe to some kind of RSS channel and also read these commands which are coming to this RSS. We can use Tor, and Tor was used for a lot of malware. In the mainly 99% of the malware for Android is using Tor to get the URLs of the sites he's going to shoot after, with every kind of payload, of every kind of data which is mining in the phone. And also this way is very as my favorite, because it's not so obvious. For example, we have here an example of the Russian state hackers use Britney Spears Instagram post to control malware. And as we can see here, we have an example of a comment, which here is how it looks like. Where are the special characters creating a special link to the malware to control it, for example. And the Twitter accounts or Twitter bots works in the same way as here we can see in the Instagram example. And we can use also a proxy chain rotator, rotations of proxy, and many other ways. This is only one of many. So now I am in the end of the first part, and I'm not going to talk anymore about Android devices and the malware. Now I'm going to talk about the second part, the server, which is recollecting the data. And we call it something like data sources, because as we can see, we can have a control of someone's phone, but we don't know who is the user who is really using our malware. And we call the data sources everything which can get retrained or to get data from the user. And malware can be a data source, a closed API can be a data source in our case, and also a leak can be a data source. So for example, to make the OSINT process of looking for which kind of person has installed our application, we can generate a OSINT centrum, which is going to make this task very easy for us, and we can set up for our needs. For example, here we can see which is the structure which I was using before with the command and control server. I was infecting the devices, and not all the devices need to be controlled by me. For example, I am only sending a command to one device, and the second one can still be working as a normal application. Then the user don't have to be I don't have to retrain the data from this phone, for example, only from one. So to make it harder to know where is the OSINT centrum, we make something like a proxy chain or a proxy application, or small container of a Flask application, which is sending next to the phones every kind of command we are going to send from the main one. And after, when we get the data in the main server, we launch a search with closed APIs or any kind of request or tools which are in Kali to make some kind of OSINT, and we are going to save this in a SQL database, in SQLite, to after do something more with this data. Here we can see that we have a lot of leaks in the last years. For example, in 2021, there was a Facebook leak which you can use to, for example, get the phone number of someone if you have only his name, or if you have his email, you can have, for example, his password from a Yahoo data breach, or if you have his email, you have the data breach from Google, you can have everything from him. And one of the main questions was, what if I have only one of these things? What I can do if only I have some small part of information. And for example, it led to me to generate something called a scrapping creator. And I made something in relation to Selenium plugin to my application, which leads me to generate dynamically some kind of scrappers. And here we can see which is the payload for this kind of scrapper. And he can get the steps. And for example, he has some kind of keys which are going to say to this scrapper what we have to do now. And we have to go to one URL, get this selector, wait for him until he is going to be visible in the page, if he is visible in the page. And this is every kind of thing we can make in the scrapper to generate this kind of weaponized and closet APIs already. Because, for example, there was a leak, or maybe no, maybe it was a feature, not a bug, in the Outlook accounts. When you were adding someone by mail, you are not able in LinkedIn, for example, to find someone by mail. But if you have an Outlook account and you add this mail to this Outlook account, you can have totally the information of this person. So I created a scrapper which is going to get inside LinkedIn and is going to put the mail of the person which I'm looking for, and I don't know his name, or I don't have any kind of his information like a photo or something like that. There are the steps of the scrapper, what he's doing. We can see that every kind of step has a success. So he was logging inside, clicking a button, going to other page, adding a new person, and after all, I got the media of this person. I got this photo, and I got also his name from a LinkedIn. To see what is going on down, I'm going to show the example. We can add a new contact without having this person or without knowing him at all. So I am adding a new person with the Toni. It's my mail. And as we can see, we have something here like LinkedIn, and there is all my data without having this account having me in my contacts already in LinkedIn. So it's a curious way to, for example, use closet APIs to weaponize data. The next part of scraping everything is how to weaponize leaks, and we know the leaks are itself a weapon, but for example, here I have an example of a Facebook leak, which was something around 15 gigas. And after all, I was looking for myself, because when you see that a big company like Facebook, Google, or Yahoo has a leak, so the first thing what you are going to do is look if you are not in this kind of leak. And for my, but I'm not so lucky, because as you can see here, I am in the leak of the Poland file. And if you put on to Toni Rodriguez and you grab this file, is going to find you very, very, very quickly. And if a guy like me looking in internet something like around 1 hour is able to download this leak of all around the world and have this kind of data, which is in the first place is the phone number, the ID of Facebook account, after is the name and other kind of information that you have put in your profile. I think it's a big problem to the cybersecurity or the RODO, for example, here in Europe. So now I'm going to talk a little bit about the Exif data, and the Exif data is also a good place to make some kind of weapons. And weaponizing the metadata, for example, going back to the phone example, as the same photo which I have sent before has an Exif data which was placed in this photo, and after I'm going to talk how it was placed, but we can get from the Exif data very, very important information, like for example, the localization of some person with which has the malware installed already in his phone is a good way to find where this person was and and when we can do something like a history of where this person was and trying to stalking him through photos which have the Exif data. But also a good way to prevent this is to, in mobile devices, turn off the geotags or use fake GPS applications. And here is an example where I am using a fake GPS application. I have never been in Orlando at all, but this application is defending me in to this kind of attacks, for example. And also a very, very important thing, and I think more, or this is at the same time very threatening, is the, for example, a software called FOCA, which is a fingerprinting organization with collected archives, and he is able to get from the metadata all kind of paths we can have in, for example, XML document or PDF document, and every kind of this thing. He can make a spider of all the infrastructure basing on NetBIOS names, domain names, path names, user names. So the best way to be not be a part of this kind of attack is to erase the metadata of this kind of documents or erase it completely. So I'm going to speak now about a little bit of steganography. And as I said before, the photo which I was sending from the phone to the command and control server had have a hidden message, and it was the geolocalization, this photo of the Exif data, because it was for me easier to send this photo via send this data via steganography. But the steganography is used to make worse things that only send this kind of information in a photo. This is a subliminal channel which you can, for example, have a malware which is going to deploy parts of them, taking information from the photos, and you can, for example, split all the code of one malware in a lot of photos, and after all connect to this junction to one working malware. And also a disadvantage of this kind of things, or what we have to take into consideration if we're looking for steganography, we have to see that the size of the file really increased, very, very, very increased. So when you are using something called LSB algorithm, which is the last significant bit, we are chopping bits until putting inside information. From something like 200 of kilobytes, we can generate 10 megabyte files. So it's not the best way to send information in something not noisy method. But yeah, as we can see, it's one of the ways to do this. At least I would like to speak about the image recognition, which is also a part of this OSINT project, where I am asking what if I have only a photo of a person. And as we saw before, I have retrieved the data from the LinkedIn of my image and also my name. But let's take into consideration that we have only the photo, and we install a package which is called face recognition to Python, and it's a pre-trained model which has the face recognition model, and you can put images inside, and after all we can combine with the scraping tool which I have made before, and we can scrape off pages of Facebook, for example, looking for the face of this person which we have get the photo before. And to scrape the social media, I think is the best way to make a use of scraping and face recognition. And after all, also there is a problem behind it, because this kind of tools generate something like that our biometric is no longer private, because we have here an example of Starbuck in your eyes, when a German hacker was spoofing the iris recognition of Merkel in a campaign in 2016. I don't remember really. we have here the source if someone want to read about that. And now I would like to have, sorry, now is the end of my presentation, and I would like to give a special thanks to Maciej Krzyżaniak, which was helping me a lot and gives me a lot of help doing this presentation and this work at all. I would like to give a special thank to my friends too for their support too, for my parents for everything, and for the ZIFCON organizers for this change to be a part of this conference.